Okay, our last presentation in this session is a virtual presentation from Sarva Mangala Praveena, who is an associate professor of environmental and occupational health at Universiti Putra, Malaysia.
Thank you, Sarah.
There we go.
Okay, thank you so much. Hi, everyone. My name is Sarva Mangala Praveena. I'm from Universiti Putra, Malaysia. So this is the title of presentation to investigate microplastics in Malaysian bottled water brand and also to know the potential human exposure. So as all of us know, microplastic has been reported in a variety of food products. It can be from salt, sugar, the packet product like milk, and also seafood. So the detection of microplastic in humans stool indicated that there is an intended microplastic consumption from a variety of sources that in a long run, we can see some negative effects on human health. In Malaysia, there's a growing interest to investigate and know the prevalence of microplastics in environmental media, but the quantitative findings are still limited and growing. When we look at the microplastics in food sample studies in Malaysia, there's only few reported so far. The reports are available for commercial fish and as well as bivalve. So to see and to understand further a microplastic in food sample, there is a tendency microplastics are potentially also present in bottled water sold in Malaysia, and also in line with World Health Organization, which has stressed the importance of assessing the microplastics level in bottled water and to explore the health risks associated with microplastic consumption. So when we look at plastic bottled water sales in Malaysia, it's in increasing trend, which can be linked to several factors like consumers' growing health and wellness awareness. We do have in few places and once in a while where poor perception of tap water quality, because most of the respondents do complain about the odor and perceived chemical taste being reported for tap water. So there are two types of bottled water available in Malaysia. One is from natural mineral water. Second is packet drinking water, which can be differentiated by bottle cap. The white one is actually a treated tap water derived from river. It goes several treatment and packed as bottled water. The green and the blue one comes from underground water table, filtered and tapped at spring. There are two authorities responsible, one for the monitoring of bottled water quality. The second one is to which is responsible for raw water supply quality. So far, there's only 2 studies available involving bottled water qualities in Malaysia, and both of these studies investigated in terms of heavy metals. So the objective of this study is to investigate the presence and characteristic of microplastic particle in 8 bottled water brands in Malaysia, and then to explore the potential sources and estimate the daily intake of bottled water to understand further in terms of human exposure. So these are the whole methodology in this study. We have 8 bottled water brand. The first to this 6th bottled water brand is actually mineral one, and the last 2 is actually drinking water, which can be identified based on the white bottle cap. These are all the quality control and assurance steps taken. And for results and discussion, microplastic particles were found in all the 8 single-use bottled water brand, which comes from various water sources. And then the one sample t-test showed there's a significant difference between microplastic in bottled water and blank. Then these findings suggest that there are various other sources which can be related to the occurrence of these microplastics in bottled water. The highest microplastic particle were identified in the packed drinking water, which the raw source comes from the municipal tap water that has undergone conventional drinking water treatment. The lowest is in sample E, is actually the raw water is extracted from underground natural water sources. And for shapes and color, we found that fragment dominated the most in terms of the shape, and the color is actually transparent. And we have a slight percentage of other colors like blue and green, which we feel that it's actually related to bottle cap of each bottled water that we have investigated. These are few of the images of microplastic particle found in bottled water. And FTIR spectra identified most of these particles are polyethylene terephtalates, PET, and polypropenyl, PP. And it suggests comes from packaging material and bottled water. So to explore more in terms of possible microplastic sources, from the literature, it found that the fragment shape normally associated with the release from the cap and the packaging material itself. It can be during the bottling process itself or during transportation. Furthermore, the consumer's behavior like squeezing, shaking, frequent opening and closing can also release microplastic particle in fragment shape. Furthermore, thermal impact during storage do enhance the fragmentation process, and the cap friction due to frequent opening and closing can also make the microplastic particle which matches the blue cap that we saw just now. For estimated daily intake, these are the value indicated, and the overall EDI value provides indication that there's a risk associated with microplastics that we should not be underestimated. Furthermore, there are few other parameters that we think important to be studied in future study, like bottled water bottle material quality, consumption behavior, as well as the storage condition, and to study on the frequency of opening and closing of bottle cap. So this is the conclusion of the study. Microplastic particles were found in all the 8 brands of bottled water. The highest were found in packed drinking water, the lowest from the underground water table. The highest microplastic particle shape is fragment and in transparent color. PET and PP is the most found polymer type, consistent with previous studies, which the sources can be related from packaging material and bottle cap. So although the EDI values are low, but the potential risk to human cannot be underestimated due to presence of other plastic additive and monomer in this particle. With that, thank you so much.
Thank you very much. Are there any questions? We do have time for a question or two.
What was the lowest or the smallest size particle you were able to pick up by your methodology?
The smallest, here we presented in particle per liter. We did not try to record the size, I think due to the methodological limitation. It's a bit difficult to measure the size because we didn't use the dye method to dye the particles, so it's a bit hard to measure the size. So that's why we opt for to present the data in particle per liter.
Any other questions? Okay, thank you very much.
Thank you so much, Sarah.